Hello? Hello? Hello, good afternoon. Hello? Hello, good afternoon. Hello, good afternoon. Hello, Caleb. Hello, good afternoon, Caleb. Caleb. Hello, Caleb.
I can hear you, sir.
Good afternoon.
Good afternoon, sir.
How was your day?
Fine, sir. We thank God, sir. And you, sir?
Yeah. Today we will continue with our class. Last week, remember we did introduction about the work last week.
Yes, sir.
So I don't know, can you still remind me what we did last week?
I wasn't in the last class, sir.
I didn't bother to look at the recording.
Because I actually traveled. I just came back, so I saw the notification on my mail. So
anyway, no problem. Anyway, let's start for today. Today we want to talk about different type of motion. Can you see the slide?
Yes, I can see the slide.
So we want to talk about different type of motion of the earth.
Okay, sir.
So here we will talk about the three basic type of motion of the earth. We're talking about the rotation, revolution, as well as the wobble. That is the movement of the earth along its axis. That one is regarded as rotation. The movement, the rotation of the earth around the sun, that one is a revolution, as well as the other type, which is wobble motion. Each of these type of motion has a peculiar features attached to it.
Yeah.
For example, let's look at what we, at the end of today's class, we will be able to describe the three main types of motion of the earth. We also state the effect of each of these three types of motions. You will be able to see in a diagram the two hypotheses that guide the rotation of the earth. Also, we'll be able to explain the variation in density as a result of the rotation or the centrifugal sorting of the earth. Now let's start with the class.
Okay.
Firstly, when you are talking about the three types of motion, I told you we have basically three types: rotation, revolution, as well as wobble motion. So all this motion of the earth is as a result of the non-stability of the planet. That is, the non-stability of the planet Earth can be manifested in various ways, in various features, such as the occurrence of day and night, the seasonal variation, as well as the annual irregular length of days and nights, are some of the events that exemplify the movement of the earth. Like I told you before, we have three types, but each of these three types has a peculiar features or peculiar effect that is associated with it. For example, there is a particular type of motion that can account for the occurrence of day and night. There's also a type of motion of the earth that can account for seasonal or climatic variation. And also there is a motion of the earth that you can use to explain the irregular length of days and nights. So as we move through these topics, we see each of the motion that is associated with a particular features. So we will examine the various modes of motion like the rotation, revolution, wobbling, as well as their effects, such as centrifugal sorting and the oblate nature of the earth. Now let's first of all talk about the first type of motion of the earth, that is rotation of the earth. Have you heard of the word rotation before?
Yes, sir.
So how can you describe the rotation when you say something is under the influence of rotational motion? That is, the object is moving around its axis. So the earth, in order to maintain dynamic equilibrium with other planets, as well as with other heavenly bodies, undergoes series of complex motions, such as rotational motion, revolution motion, as well as wobble motion. But the three major types of motion whose effects are observable in our daily life are three. Basically, they are rotation, revolution, as well as the wobble motion. So let's first of all talk about the revolution. So revolution of the earth is talking about the movement of the earth around the sun. Are you with me?
Yes, sir. We are with you, sir.
I said revolution of the earth is talking about the movement of the earth around the sun. The earth moves along an elliptical orbit whose plane is fairly perpendicular to the polar axis of the earth. So when we are talking about the elliptical orbit of the earth, we have two principal focus. We have F1 and F2. And this F1 and F2 are the focus of the orbit, with sun at one of the foci. You will see it in this diagram. Now, if you look at this diagram, you have F1, F2. You also have the Earth as well as the sun. So the sun, the Earth is moving around the sun in an elliptical orbit. Out of these two foci of the Earth, so the sun is at F1, while the other one is at F2. So this revolutionary motion of the Earth has a period of 365 days. That is a period of 365 days, that is a year, and also determine the global season. In other words, when we are talking about the effect of this type of motion, revolutionary motion is the one that accounts for seasonal changes. In other words, the seasonal change is brought about as a result of the movement of the earth around the sun. And it is explained by this statement: the seasonal change is brought about as the result of Earth's distance from the sun at each location on its orbit. For instance, if you look at this figure, at location B, this is location B, and this is location A. At location B, the Earth is far from the sun. You can, if you take the distance from this Earth to the sun, you see that F2, the distance from the Earth to F1, is more bigger. That is, the distance, the location B is at a vast distance from the sun. So this location B may not be much to cause enough evaporation for much rain because it is far away from the sun. Also at location A, at this location, the Earth experiences much heat of the sun's ray. Can you tell me the reason why? Why location A experiences much heat of the sun rays?
Because it will be closer to the sun.
Hello?
Yes. Because it's closer to the sun, sir. Hello?
Hello?
Yes, sir. I can hear you, sir.
Philip?
Sir.
Hello?
Hello, sir. I can hear you, sir.
But I asked a question. You say you can hear me. I asked a question. You didn't reply at all. You didn't respond.
Yes, I replied. I said because it's closer to the sun, sir.
Okay, because I didn't hear you. Sorry. So location
Yeah.
A experiences much heat of the sun's ray because it is closer to the sun. And you know that location B is far away from the sun. That means
Yes,
it will not experience much heat. Eh? So since it didn't experience much heat, so there will not be enough evaporation to cause much rain. But location A that is very close to the earth experiences much heat. This now causes intense evaporation that now leads to rainfall. In the north, so what I'm saying is that the revolutionary motion of the earth accounts for seasonal changes. And the periodicity of this revolutionary motion is a year. And this revolutionary motion brought about seasonal changes as a result of the Earth's distance from the sun. So another thing that you must know about this revolutionary motion of the Earth is that apart from the fact that the movement of the Earth around the sun is in a particular orbit or path, it causes changes of season. And we have already mentioned that. And it takes 365 days. But you know that there are some years that are more than that the number of days is more than 365. We have leap year.
Yes.
Can you tell me what accounts for that extra year? You already knew now that revolutionary motion is the one that causes seasonal changes. And it has a periodicity of 365 days. Now we have a leap year. So what accounts for this leap year? Hello?
Hello, sir.
So can you tell me what accounts for, the normal
Yeah,
day of
you,
the year is 365. Yes? But we have some years that are regarded as leap years. And the number of days in leap year is 366 days. So I'm now asking you, can you tell me what accounts for that extra day in a leap year?
Based on my own idea.
Can't hear you.
It has to do with the season. Okay. I said based on my own idea, it has
Hello?
to do with the season. Hello, sir.
Can you hear me?
Yes, sir. Yes, I can hear you.
Then can you respond to my questions?
Yes, sir. I said based on my own idea, I guess it's the seasonal changes that is brought about from the Earth distance to the sun.
That brought about leap year.
Yes, sir.
That is 366 days. Anyway,
yes, sir.
the actual period of that the revolutionary motion take place is 365 days plus 6 hours. But we usually neglect that 6 hours. Now, if these 6 hours now occur for 4 years, that one will roughly make up a day. So you know that, and you also know that we normally observe leap year every 4 years. So
Yes,
these 6 hours that we usually neglect. So if we now add it up for 4 years, it will roughly make 24 hours. This is a day. And that accounts for 366 days in leap year. Hello?
Yes, sir. We can hear you, sir.
So that accounts for 366 days. Hello, can you hear me?
Hello?
Hello, can you hear me now?
Yes, I can hear you.
I've already explained to you why we have 366 days in leap year. I want you to now explain it back to me.
Okay, sir. You said, based on what I understood, it's because of that we have 365.6 hours
Yes.
and neglect the 6 hours. So
Yes.
if that occurs 4 years, multiplying that's an extra day, which makes it 366 days.
Thank
Yes,
you.
366 days.
366 days.
Yes.
You know that extra 1 day.
Yes, sir.
So that is the reason why we normally have 366 days in the leap year. Now let's move to the.
Sir, I want to ask a question, sir.
Ask you.
Hello, sir.
Hello, I can hear you.
Yeah. Why do we have a time difference in different parts of the world?
Time difference. Is that one out of the 3 types of motion? Do you think which one which one do you think normally account for day and night?
I think it should be rotational.
Eh?
I think it should be rotational.
And then why can't you wait till when we get to the rotation? And we are talking about the revolution motion of the Earth that accounts for seasonal variation. So this wobble motion is the. Hello?
No problem, sir. No problem.
This is not a matter of no problem. You ask a question and I ask you a question back that the revolutionary motion is the one that accounts for seasonal changes. Okay? But you are now asking me a question that what accounts for time difference around the world. And that one, the type of motion that accounts for day and night is the rotational motion of the Earth, which is the movement of the Earth about its axis. But we are talking about the revolutionary motion of the Earth. So let's continue. So for this type of motion, wobble motion, the Earth exhibits a flip-flop motion about its equator as it's revolving around the sun. You can see from this diagram. It's to be noted that under this wobble motion, that the northern hemisphere is closer to the sun than the southern hemisphere. The northern hemisphere is closer to the sun than the southern hemisphere. Therefore, if northern hemisphere is closer to the sun than the southern hemisphere, so the implication is that the northern hemisphere will experience this longer day and shorter night at this time. Now I want to ask you, but the reverse is the case at location B. So the guy that asked the question, why do we have time difference? Then look at this statement. The northern hemisphere experiences longer day and shorter night. So the question that the thing that you're supposed to know is that, like we in Africa, so you ought to know whether we are at the southern hemisphere or at the northern hemisphere. But this statement will now answer the question that if you have a particular location that is located within the northern hemisphere, they will experience this longer day and shorter night for this type of motions. But the reverse is the case at location B. So if the reverse is the case at location B, that means location B is at northern hemisphere or southern hemisphere?
My name is.
Hello?
Yes,
I'm asking you, they said northern hemisphere is closer to the sun than the southern hemisphere. There is a pre-statement that northern hemisphere is closer to the sun than the southern hemisphere. Now, they now say that the northern hemisphere experiences longer days and shorter nights. But the reverse is the case at location B. So I'm now asking you, out of A and B, location A and location B, which one is at the northern hemisphere and which one is at the southern hemisphere? Hello?
sir. Question, sir.
That means I will continue with the class, so because I don't like a situation whereby I'll be asking you a question and you will not respond. This diagram, you have location A and location B. And from the statement on this slide, they said that the northern hemisphere experiences longer day and shorter night, and the northern hemisphere is closer to the sun. But the reverse is the case at location B. I'm now asking you, this location B is at what hemisphere? Is it at northern hemisphere or southern hemisphere?
It's our southern hemisphere.
Why? Why did you say that?
Because it will actually a shorter day and a longer night. Because it's closer to the other.
Is it closer to the sun? It's far from the sun.
Far from the sun, sir.
So what I think is, according to the diagram, the location A is giving us a left flip. And that means the northern side is rotating to flipping towards the sun. But on the B diagram, it's giving us a right flip. That means it is flipping outside, like going away from the sun.
You mean the one on the location B?
Yes, sir.
So the left flip is towards the northern hemisphere, right? And the northern hemisphere
Yes,
is
sir.
closer to and the northern hemisphere is closer to the sun. Why the right flip is tilted towards the southern hemisphere, and the southern hemisphere is far away from the sun. Now this rotational motion, this is a movement of the Earth about its axis. That is, this is a rotation about polar axis from west to east in an anti-clockwise direction. So the average period of the Earth's rotation is 86,400 seconds. In other words, the average period of Earth's rotation is a day. Therefore, the rotation of the Earth determines the length of the day and night. So the type of motion of the Earth that determines the length of the day and night is rotational motion. So this rotational motion causes ellipsoidal shape of the Earth. And also this rotational motion results in density variation from the surface to the center of the Earth. Now, there are two hypotheses that guide the rotation of the Earth. So the first one is Cassini hypothesis, while the second one is Newtonian hypothesis. So the Cassini hypothesis proposed that the Earth is rotating about the equator with the polar axis perpendicular to the axis of rotation. However, the Newtonian hypothesis, that one proposed that the Earth is rotating about the polar axis, which now leads to oblate ellipsoidal shape of the Earth. What I mean by oblate ellipsoidal shape is that the equator is longer than the polar radius. That is the meaning of oblate ellipsoidal shape. And the geophysical evidences support this, that the geophysical evidence such as longer equatorial radius than the polar radius as well as centrifugal shortening of the Earth lead to density variation, whereby we have a density increase from the surface and it increased toward the center. And as we said before, this rotation motion of the Earth led to occurrence of day and night. In other words, this Newtonian hypothesis that assumes that the Earth is rotating about its polar axis and that the Earth has an oblate ellipsoidal shape supports the fact that there will be a density variation, that the density will increase from the surface toward the center of the Earth. And it also supports the occurrence of day and night as a result of rotational motion of the Earth. Now, the rotational motion of the Earth will have some effect on the internal structure of the Earth. Remember that last week we talked about the ion catastrophe. And we said that during the ion catastrophe, when there is release of particles, this one will lead to the emission of the heat energy that will now make the ion to melt. So given that the fact that the Earth was initially melted, it states that it's regarded as ion catastrophe. So we said that during the ion catastrophe, the lighter particles of the crust will be sent to the flanks, while the denser and homogeneous mantle and the core material remain closer to the center of the Earth. So for those of you that attended the last week class, can you tell me the three parts of the Earth that we have?
Three what, sir?
The three parts of the Earth. Parts.
The crust, the mantle, and the core.
So which one is the inner one and which one is the outer layer? You said we have three layers of the
core,
Earth: the core, the mantle, and
the core is the inner layer, followed by the mantle, and the crust is the surface.
So which one resulted as a result of the melted iron?
Core.
The core. And it has a higher temperature compared to the other two. So geophysical studies have confirmed that the crust is inhomogeneous in nature. They are denser. We have a denser core as well as homogeneous mantle. So the Earth rotates about its pole with the angular velocity of 7.292 times 10⁻⁵ rad per second. So as the Earth rotates, both centrifugal and centrifugal force will cancel out. So when both centrifugal and centrifugal force cancel out, that is when CF is the centrifugal force, while CP is the centrifugal force. As the Earth rotates, the two forces, CF and CP, will cancel out, and the net force will be equal to 0. Therefore, there will not be any deformation along the equator of the Earth. And the reason is that because the two forces that act during the rotation of the Earth, that is the centrifugal force and the centrifugal force, cancel out. And since the net force is 0, there will not be no deformation will be along the equator. Now, this centrifugal force decreases towards the pole from the equator. The centrifugal force decreases towards the pole from the equator. Therefore, there will be a net force towards the center of the force, which also increases in magnitude as we move away from the equator. Now, look at this statement. The centrifugal force decreases towards the pole from the equator. So which parts of the Earth we have a maximum value of centrifugal force? Hello?
I can't hear you, sir.
Can you see the current slide?
I can see this slide, sir.
Now, I'm now asking the question. If you look at the first paragraph is saying that the centrifugal force decreases towards the pole from the equator. So I'm now asking you, so which of the part of the Earth will now have the maximum value of the centrifugal force?
Yes, I could barely hear you. The network was very bad. But according to what you said last week.
But I can hear you. I can hear you clearly now. Me, I can hear you clearly. I don't know what. I don't know. The centrifugal force decreases to 0 at the equators. So, and we have a maximum centrifugal force at the equator. So that one will now give us, that is the net force, directed to the center is obtained at the pole. Consequently, the polar region are flattened and the equatorial region bodies outwards. So the Earth now assumes the oblate spheroidal nature. And I told you before that when the equatorial radius is longer than the polar radius, we have what is known as oblate spheroidal nature. Now let's look at the factors that is responsible for the shape of the Earth. The surface of the solid part of the Earth is not smooth, but there are some factors that account for this. And the first one is gravitational pull. After ion catastrophe side, particles experiences gravitational pull from the interior of the Earth. So since this pull is from all directions around the solid Earth, so the Earth now appears fairly spherical. That is the first factors that account for the spherical shape of the Earth. So another factor that accounts for spherical shape of the Earth is volcanic eruption. This spontaneous volcanic eruption from the interior of the Earth sometimes come out to the surface and now form features such as continental platform and mountains. This also supports the spherical shape of the Earth. Also, the interaction between the lithosphere and the atmosphere and hydrosphere. That is the interaction between the lithosphere as well as the atmosphere and hydrosphere also can be used to explain the spherical shape of the Earth. And also, there is what is known as plate tectonics, and this is the movement of the Earth around the plane. Plate tectonics, this refers to the significant movement noticeable on the Earth, so on the Earth layer called plate. These plate tectonics account for some of the processes that we can see. For example, sea floor spreading, earthquakes, continental drift, faults, dike, and so on occur as a result of plate tectonics. Now, because they have already contacted me that the class will end in the next 5 or 10 minutes. Now let's quickly revise what we learned today. Basically, we talk about different types of motion of the Earth, and the one that is the one that will be of concern to you are 3. They are revolution, rotation, as well as the wobble. And we said that the first one that we discussed is revolution motion of the earth. That one is the movement of the earth or rotation of the earth around the sun. And we said that that one accounts for seasonal variation. That is, the seasonal changes is brought about as a result of the Earth's distance from the sun. We also said that the rotational, the wobble motion of the Earth, this one, it's a type of motion that accounts or that provides the reason why some places experiences longer day and shorter night, while the reverse is the case at some other places. And it is due to the flip-flop motion of the Earth about its equator. Then we also talk about the rotational motion of the Earth, and this is the movement of the Earth about its polar axis. And it has a period of a day, 1 day. Therefore, the rotation of the Earth determines the day and night. And also, when we are discussing about the revolution of the Earth, we said that the periodicity of the revolution motion is 365 days plus 6 hours, but that we usually neglect these 6 hours, and that every 4 years, these 6 hours will now accumulate from 24 hours, which is probably a day, and this accounts for an extra day. And this accounts for an extra day that we usually experience during leap year period. Now, I want you to do one assignment for me. Hello? Hello?
Yeah, with you, sir.
With you, sir.
I said I want you to help me do one assignment. I don't know, maybe there is one of you that asked the reason why. Is it Caleb or there's one of you that asked the reason why there is time difference around the world?
Yes, sir.
Hello? So can you find the answer to that question here now? Or I want you to do it as an assignment, and you can submit it to me through the email address. The reason why we have time difference. But from this little introduction about the 3 types of motion, which one do you think we account for time difference around the world? Is it revolutionary motion or rotational motion or wobble motion? Hello? Hello?
Hello, sir.
I said the question that one of you asked, because this is teacher-student interactions. I said, I want you to do an assignment for me. And the assignment is that I want you to explain why there is time difference around the world. And I ask you, from this little introduction about the 3 types of motion of the Earth, which one do you think is responsible for time difference around the world?
For me, sir, it's the wobble motion.
It's wobble motion, Adi?
Yes, sir.
Why?
Because the Earth exhibits a flip-flop motion.
No. I want to, but let me give you a guide. You know, there is a place in Africa is located at what part of the
place will be at Okay,
Hello.
sir.
Hello, sir.
Yes, sir.
So if you know a particular place where if you know the side of the hemisphere at which a particular place is located, no one can guide you. But I think the person that say wobble is responsible, but it is not as a result of rotation. It is not as not as a result of the revolutionary motion of the Earth. But to be between rotation as well as the wobble motion. But I want you to do it as an assignment and submit it to my email address latest by, today is Wednesday, latest by 10 a.m. on Friday.
Okay, sir. All right, sir.
So maybe you have, hello?
Yes, sir.
You have my email address now.
Yes, sir, we do.
Yeah. So the next class will be on when? When? Is it on Saturday or next week, Wednesday?
Anytime, sir.
Anytime is no time now.
Okay, sir. Let's fix
Anytime.
it up.
Can we do it tomorrow?
Let's see on Saturday, sir.
Can we do it tomorrow?
We have other classes tomorrow, sir. What time would you be available on Saturday, sir?
On Saturday, what of maybe 4?
Okay, no problem.
4 p.m.
4 o'clock, sir.
Okay, sir.
4
p.m.,
o'clock.
sir.
Okay, please
Okay,
let's keep a day for that 4 o'clock on Saturday. You know, this is the first week and this is the second class, so that we'll be able to cover up. Although the lecture note is not that too heavy, but I need to add some extra lecture notes that can be useful. So we meet next week.
All right, sir.
Okay, sir.